Today's lesson is on similar triangles. Two figures are similar if their corresponding sides are proportional to each other and their corresponding angles are congruent. The same rules apply to triangles, but you can determine if they are similar by using a lot less information. Two triangles are similar if one of the two requirements are true. They don't both have to be true, just one. So we can have any two of the three corresponding angles are congruent. Well, when all triangles have angles equaling 180, then if two of them are going to be the same, then the third one has to be the same. One pair of corresponding angles is congruent, and the corresponding sides adjacent to these angles are proportional. So you don't need all the three sides, you just need two sides and the angle that's in between. So let's take a look what this looks like. So situation number one is here. Two angles, corresponding angles are congruent. So this one is 18, this one is 18. The bottom angle is 95, the bottom angle is 95. That means that this angle has to be equal, and so these two are similar. The second triangle, we have 92-degree angle in between two sides that are proportional. So the 26 over 13 is a scale factor of 2. So times 2 gave us 36, and times 2 gave us 16. So we have two proportional sides, and the corresponding angles is congruent, so those two triangles are similar. Determine whether right angles are similar is even more straightforward. A right angle always has a known 90-degree angle. So we know that this one is 90 degrees, and that has to be equal. And we know that the 35-degree angle, corresponding angle, is similar. So we do have similar triangles. So with a right triangle, you only need one pair of corresponding acute angles to be congruent. But that's only for right triangles because we are already aware that there is a right angle in there. Okay, does the size of two or more triangles influence whether or not they are similar? Well, the size doesn't influence them. It is dependent upon congruent angles that are the determining factor. So if congruent angles or corresponding angles are congruent, then they are going to be similar. Look at the three triangles below. Are they similar? Why or why not? Well, when you're looking at these triangles, they're in different positions on the picture. So we have to look to see, well, we have a 78-degree angle here, a 78-degree angle here, and a 78-degree angle here. So we do have a corresponding angle that is congruent. But we need to see if our sides are, the corresponding sides are in proportion. So these three sides are corresponding. So even though the sides are in different positions, they are still corresponding. So let's take a look at these two. We have 12 over 4, 6.2. So that's a scale factor of 2. So times 2 got me to that one. Let's take a look at these two corresponding sides. 9 over 4.5. And that is also 2. So to go from here to here is times 2. So those two are similar, the one on the left and the middle one. Let's take a look at the second triangle. So we have 3.1 and 9. No, sorry, 3.1 corresponds to 12.4. So that scale factor is 0.25, and 2.25 and 9 correspond, and that's also 0.25. So these two are similar. Okay, so I have a reduction going here times 0.25. Oops, this one. Okay, in triangle ABC, the side length of AC is 7. So what is the new side length DF? DF, so we take 7 times the scale factor of 2 would be 14 centimeters. And MO, the scale factor of 0.25 between, we could go times 14 equals 3.5. Okay, so I used this length here and changed it times 0.25 to get 3.5. Okay, there's the answers typed up for you if you need to see them a little easier. Adilcia is designing a t-shirt and wants to use several triangles in her design. She drew the triangles A, B, C to represent the triangular shape she wants to use in her design. The side lengths of the triangles are shown. Okay, so here this is given to you, and you have one triangle, big triangle on the outside, a little triangle on the inside. So to make it easier and to put the dimensions on, I'm going to redraw them. So this is A, B, C, 6, 4, 5. And that's all given to you. And the smaller triangle is E, C, D, and 3, 2.5, and X. Okay? So she thinks that if she draws ED so that it's parallel to AB, then the triangle ABC is similar to EDC. So let's see if these two triangles are similar using our scale factor. So we have to find corresponding sides and calculate the scale factor. Now this is the scale drawing because it's the one that doesn't have all the dimensions on it, and this is the original. So we're going to take the scale 3 over the original 6, 0.5. We're going to take the scale 2.5 over the original 5, and it's still 0.5, so I know my two triangles are similar. So how do I find X? Well, if I take my original times my scale factor, I find out that ED is equal to 2. Okay? Are these two shapes similar? Well, we know the sides are in proportion, but the third part, okay, it means that we need the angle in between those two sides to be congruent. Well, here you'll notice this is angle C, and this is also angle C. So angle C has to equal angle C. Because they're the same angle. So these two triangles are similar. Okay, notice that in your notes it says congruent. Please change that to the word similar. So that angles are congruent, the triangles are similar. Okay, Roberto and Marco set wires to either sides of an artificial tree as part of a setup for a Christmas concert. They decide to attach the wires so they both make a 33-degree angle, okay, within a right triangle. Are the right triangles created by the wires similar? So if you go, remember what I discussed earlier, right triangles only need to have one acute angle that is corresponding angle that is congruent, and so these two triangles are similar. A fire ranger made the following sighting from his tower and predicted the distance to the fire. Find the distance from the tower to the fire. So we want to know this distance here. Now, our triangles aren't in the correct position to look at which side are corresponding. So be careful. We have the right angle here. This 4 corresponds to 8, okay? And 7 corresponds to the unknown side of X. Okay, this is the scale, and this side triangle is the original. Okay, the original always has all the dimensions on it. So a couple of different ways to solve this. We could figure out the scale factor. So the scale over the original, the scale factor is 2. We could take 7 times 2 and find out its 14-kilometer distance. Okay, the second method is a ratio method. So you have 8 over 4, and instead of reducing it, you could just set up the other ratio on the other side, scale over original. Okay, cross multiply, and we'd find that 4x equals 56 and x equals 14 kilometers. So this question still uses scale factor. Just make sure that you are comparing the corresponding sides, that you're just not assuming which ones. So take a look at where the right angle is. You might want to redraw this triangle. Okay, so it's in the same position as the big triangle, and then you can match up the corresponding sides a little easier. Okay, I want you to build your skills and practice your skills for this section. When you feel confident with this material and are ready for the exam, you can go on to doing the chapter test review. And again, the instructions are attached to the last 2 pages, the ratio method and the parallel method, on how to do enlargements and reductions without calculations.